So our next FRQ type that comes up on almost every single AP exam is linear motion. So how do we know we're looking at a linear motion problem? They're going to say this thing is moving back and forth along a straight line given by some function. And these might be a little bit different because they might say the velocity of this thing moving along a straight line. They might say the position of this thing, the acceleration of this thing. All right, so they'll be a little bit different. But if something's moving along a straight line, then it's a linear motion problem. And also notice the particle. A lot of times they will use the word particle because it kind of robs it of any reality. But it can be anything. So they might say this person's riding a bicycle along a straight line. This airplane's flying in a straight line. If anything's in a straight line, then it's linear motion. An important thing to remember with linear motion is this kind of physics application is probably one of the most common and important what's the word I'm looking for? Uses for calculus? I don't know which word I'm looking for. But remember, there's a relationship between position, acceleration, and velocity. So if we have position, if we take the derivative, we get velocity. All right, and velocity has a sign. So if it's positive, I'm moving right or up. If it's negative, I'm moving left or down. So velocity has a direction and a magnitude. Speed is basically velocity without a direction, so it's just the absolute value of velocity. So even if I'm moving left at 20 meters per second, my speed is just 20 meters per second. So speed is just velocity without the sign. Acceleration is the derivative of velocity. It's the second derivative of position. And acceleration also has a sign because you need to know kind of which direction you're trying to go in. And then going backwards, if I take the antiderivative of acceleration, I get back to velocity. Antiderivative velocity gives me back to position. So I like to think just position, velocity, acceleration. That's derivatives. Going backwards, I have to take antiderivatives. All right, so you can't get around that, but we've been doing that for a long time, so hopefully you know that. All right, some other kind of words that might get used. The displacement is kind of just the difference between where you started and where you ended. So if you were to like walk a mile and turn around and walk back a mile, your displacement is actually 0 because you haven't moved from your original place. So you actually want things to cancel out. So you just take the integral of velocity. It gives you the difference in your position. The total distance you covered, if I walked a mile, turned around and walked a mile back, my total distance is 2 miles. I don't want that distance to cancel out even though I'm covering the same steps. To do that, if you want nothing to cancel out, you put absolute values around a thing, and that'll make sure things don't cancel out. The final position can be calculated using the accumulation of change formula. So my starting position plus the integral of its derivative, which is velocity, that'll give me my ending position. So this is the accumulation of change formula. This comes up a lot. Okay. And then remember, your speed is increasing if your velocity and acceleration have the same side. So if I'm going to the right, my acceleration is also going to the right. That's going to pull me to go even faster. All right, so here's the question from the 2022 exam about particle motion. So they have a particle P that's moving for one formula, and a particle Q, its velocity. So make sure, again, you're reading. They're giving you different things. The velocity of Q, and it's actually nice they name them slightly differently, is given by this. They also give you the starting position of the particle Q. All right, so now, again, it would be a good exercise. Try to pause the video to see if you can come up with an idea of how you would tackle any of these. All right, so question, or part A, what is the velocity of particle P? Well, they gave you the position. You said take the derivative. So as long as you take the derivative of this expression correctly, that's going to be your answer for part A. And you get 1 point for doing your derivative correctly. Part 2, find the acceleration of particle Q, and then find all the times when the speed of the particle is decreasing. So finding the acceleration first should be pretty straightforward. They give you the velocity of Q. The acceleration is its derivative. So that's your first point, just like part A, pretty much the same thing. If we're trying to figure out if a speed is increasing or decreasing, we want to consider the signs. So think about, are these signs going to be the same? And if you look at the graph or the functions, the acceleration is always negative for a positive time. The velocity would always be positive for a positive time. So it's kind of, you could do your sign charts and everything like that, but this is, again, the ideal answer, doing it as quickly as possible. So just thinking about the signs is going to give you a point. And then, again, the answer with justification, justify is a big word there. The answer with the justification, these are opposite signs, so the speed is always decreasing. So my answer is decreasing because acceleration and velocity have opposite signs. All right, part C, find the position of the particle. So we had velocity. We know if we anti-differentiate velocity, I can get position. And they did it using, it's kind of a weird broken integral. They did it using the accumulation of change formula. So we knew our starting position is 2. We know the integral of this ends up being all of this. And then if you calculate it slowly, you get your answer. The other way you could do this, you could do it using differential equations. You take the integral, you have a plus c, and then you use that initial value to find c. So that's, I think this one here. You can solve for c to get your final answer. So multiple ways you can do this, and that gives you 3 points. But again, to find position, I have to take the antiderivative, the integral of velocity. And as t approaches infinity, will the particle eventually be going farther from the origin? So t is going to infinity, which means now we're doing a limit. You can't actually plug in infinity, so I have to do a limit. The particle for p, its position was given to us, so I just use that position. E to the negative t goes to 0 at infinity, so my answer is just 6. Q, 1 over t, also goes to 0 at infinity, so my answer is just 3. Which one's farther to the right? It's 6. It's interesting, you only need one correct limit to get the first point. All right, so if you just can do p, you still get 1 point. But of course, to get the answer right with a good reason, you need to do both. And then one interesting thing here, if you get the wrong answer in part C, you can still earn this point as long as everything mathematically you do right. Your answer might be wrong, but like if everything you do mathematically is right, you can still get both points as long as it's consistent with the answers you actually get. There's just one thing, if you made the position here way too easy, and it was just like 3. If it's a linear or a non-constant function, then you don't get credit because it's just too easy, which is a little annoying. But you can see there's ways to earn points even if you didn't get the previous part right. All right, so again, maybe you could do all of A, all of B. You got C wrong, and you got like just that first point for getting one of the limits right in part D. All right, that's 5 points right there. So if we can get 5 or 6 right for the things that we should instantly know, we should instantly know how acceleration, velocity, and position are related. There might be situations where you have to do something else complex after that, and that's where, okay, maybe you don't get that last point, but we're aiming for 5 and 6 is a good goal for all these free response questions. All right, so now the goal is in class, we have these 2 different free response questions now, rate in, rate out, linear motion. All right, I'm going to give you one. You're going to try it. We're going to see what we know, what things we need for that, and then we'll try another one and just keep practicing these over and over again.